Hello ladies and gentlemen, and welcome to non-right angled trig. Now, with non-right angled trig, we need to learn how to label triangles just like we did with right angled trig. With right angled trig, the starting point for our labeling was always the hypotenuse. Whether it's Pythagoras or SOHCAHTOA, we knew that what the hypotenuse was called. In non-right angled trig, we have no hypotenuse. So the way we go about this is simply label the points A, B, and C like I've done, in capitals, and capitals refer to the angle. So this here is angle A, angle B, angle C, etc. Then, in lowercase, label the sides. Side A is opposite angle A. Side B is opposite angle B. Side C is opposite angle C. I will get this right. Now, it doesn't matter which way around you do it, as long as the angle side pairs are opposite each other. Right, moving on. First rule, and there are three we're going to learn: sine, cosine, and then sine area rule. Today's sine rule, and sine rule is the easiest and most versatile. My favourite, really. So, the logic behind the sine rule is quite easy. You might notice that in any triangle, the largest side is always opposite the largest angle. So let's pretend that is 100 degrees, and this is 10 centimetres. Then the narrowest side will always be opposite the narrowest angle. So C and C. Say, for example, that could be 30, and you may reasonably expect this to be 10. So in order to set up an equation here, we could do the biggest side on top of the biggest angle on top of the biggest side might be equal to the smallest on top of the smallest. Or A over big A, C over big C. Essentially, we want the big side over big side over big angle, little angle over little side. And as long as those pairs match up, the ratios will be about the same. Now, unfortunately, the rule is not quite that easy, but that's the logic behind it. That if we take a big pair and divide them, that will be equal approximately to the little pair divided. Alright? Now let's prove the actual rule. In the actual rule, we drop a line down here and call it the height. Then, looking at the left-hand side of the equation, this becomes a right angle triangle. We look at angle C. Sine C is equal to opposite, which is the H, over the hypotenuse, which is B. Similarly, on the other side here, sine B, the angle, is equal to the hypotenuse, or the opposite, over the hypotenuse C. Now, taking both of these equations, they both have H in them. So what we can do is we can rearrange for H. On the left-hand one, we're going to multiply both sides by B. So B sine C is going to equal H. And on the right-hand side, little c sine B will equal H. Then we can equate those two equations. Because they're both equal to H, they must be equal to each other. So B sine C is equal to C sine B. And we're very close to the rule now. What we do here to get the actual rule is divide both sides by BC. And the rule we get is sine C over C, so sine of the angle over the side, is equal to sine of the angle over the side. Very similar to the logic we had before. And this can be extended to sine A over A. Now note, that's just one version of the rule. The other version is the inverse. C over sine C equals B over sine B equals A over sine A. Right. Now, knowing that proof isn't strictly required. You aren't required to memorize or anything. It's just interesting to see where it comes from. So, those are the two versions of the law. And I'll explain in examples how to use them in a second. But in general, we use this one to find sides. This one here to find angles. The reason is because when finding sides, it's easier to solve for something that's already on top of a fraction. And it's easier to solve for something already on top of a fraction there. All right. Now, it's used in non-right angle triangles if we're given two sides and an angle opposite one of those two sides, or if we're given two angles and one side. It is the most versatile one. It's the one we use most often. It takes a bit of practice to recognize when to use sine rule and cosine rule, and we will do that practice as we go through. Alright, so finding an unknown side. Now the first steps here are always the same. Label your points. A, B, C, B, C, A. Then, what do we have? Well, we have an A and an A. We have a C, and we want the other C. And because we want the side X, we're going to be going C on sine C is equal to A over sine A. You can take any two of these up above. So I can take this one and that one. Just because they're not written next to each other doesn't mean they're not the same. They're all equal to each other. Alright, now C we don't know, so it's X over sine 80 is equal to A, we do know, is 7 over sine 60. Solve from here, we want to get X by itself, we very simply multiply by sine 80. X is equal to 7 sine 60 multiplied by sine 80. X is equal to, let me grab my calculator, 7 divided by sine 60 times sine 80. .96. Alright, now finding angles. Once again, steps the same. Label the points. A, B, C. Label the sides. C, A, B. Then identify what we have. We have a C pair, and we have part of a B pair. Sorry, part of the A pair. Whoa, that's just confusing. Part of the A pair. It doesn't matter which way around you label the points, this will still work out. So, using our A's and B pairs, and because we're solving for an angle, we need to put the one on the top. So sine C over C equals sine A over A. Sine of 100 over 5.1 is equal to sine of beta over, B over 3.6. Now, multiply both sides by 3.6 to get sine B by itself. Sine 100 over 5.1 gets multiplied by 3.6, and that's equal to sine B. We haven't yet got B by itself, so as you can probably guess from now, we can take the inverse of sine B, inverse of B, so B will be equal to inverse sine 100 over sine 100. Whoa, that's ugly. Apologies. Sine 100 over 5.1 times 3.6. You can do this one in 2 steps on your calculator. If you want, you can find that first, then first find the inverse sine of it. So sine 100 divided by 5.1 times 3.6. Inverse sine of that answer is B is 44. 44.04 degrees. Alright, apologies for the errors there. Important thing is, when solving these, label the sides, identify what you have. You should have 3/4 of the equation. Each one of these is a quarter. 1, 2, 3, 4. You should have 3/4, and then it's a matter of solving for the 4th quarter. In your OneNote, please solve for that side. Thank you very much.